Assalamu alaikum. Today we will complete our chemistry AS topics. We will start with organic chemistry. It's topic 10 for unit 2, and as we know it's related for unit 2 unit 3 at the same time. Okay, organic chemistry. The first part of organic chemistry, it's halogenoalkanes. Halogenoalkanes, it's a functional group when we have alkane with one hydrogen atom replaced by halogen. This halogen can be chlorine, bromine, or iodine. Okay, the general formula of this halogenoalkane, it will be Rx, whereas R, it's CnH2n plus 1. It's very close from alkane formula, but one of the hydrogens removed, so it decreased by 1 from alkane and substituted by halogen. Okay, now the general formula can rewrite it in the different shapes. Let's start with the first one, CnH2n plus 1x, where is only one hydrogen replaced by one halogen, or CnH2nx2, whereas two hydrogens replaced by two halogens. Here it's di substituted because two hydrogens replaced. Here it's mono substituted because one hydrogen replaced. Or it can be CnH2n minus 1. Here we replace three hydrogens by three halogens, so it's tri substituted. Now, about classification of halogenoalkane, classifying of these compounds divided for three parts. As we learned in alcohol before, we have primary halogenoalkane, whereas the halogen bonded to carbon, bonded to two hydrogens and one carbon directly. We can have chain of carbons here, but still primary because this carbon bonded to one carbon and two hydrogens. Okay, secondary when the carbon which is bonded to halogen, bonded directly to two carbons and one hydrogen. Again, here we can have a long chain of carbon, but mainly our compound classified depending on the carbon which is bonded directly to the halogen. These carbon bonded directly to two carbons and one hydrogen. It is secondary halogenoalkane. Now we have the tertiary halogenoalkane. The carbon which is bonded to halogen bonded directly to three carbons, and this carbon which is bonded to halogen, it's not bonded to any of hydrogens, After that, we need to talk about reactivity of halogenoalkane. Okay, reactivity of halogenoalkane. First, we need to know why halogenoalkane reactive. It's due to the polarity of this bond, carbon halogen. We know halogens electronegativity is higher than carbon, so this bond will be polar. The halogen carry a partially negative charge, and the carbon which is bonded to halogen carry a partially negative charge. Now, this arrangement or redistribution of charges make these carbon a target to be attacked by special species called nucleophile. So the CX bond, it's polar bond due to high electronegativity of halogen, which is atom X. So carbon atom which is bonded to halogen, it will be attacked by other species called nucleophiles, which can be one of three different particles. We will explain it within a moment from now. But the nucleophile will attack this carbon because the nucleophile like or love the positive charge, and these carbon carry a partially positive charge, so it will be attacked by the nucleophiles. Now, what do you mean by nucleophile? Nucleophile can be a negative ion, like hydroxide ion, for example, okay, or cyanide ion, or a molecule with a slightly negative atom. If the molecule have an atom which is due to the electronegativity difference carry a slightly negative atom, it will considered as a nucleophile, or molecule contain atom with a lone pair of electrons, lone pair or more, one lone pair or more. For example, if we talk about ammonia, there is lone pair in nitrogen atom, or if we talk about water, there is two lone pairs at the oxygen atom. Okay, so this is the main reason for the reactivity of halogenoalkane, because we have these partially positive charge here at the carbon which is bonded to halogen, and these carbon will attacked by the nucleophiles. Okay, now reactions of halogenoalkane. The first reaction is hydrolysis. What do you mean by hydrolysis? It's reaction with water to give alcohol. Reaction with water to give alcohol, as we see here. Rx, which is halogenoalkane, react with water to form alcohol, and HX. HX, it can be HCl, HBr, or HI, depending on what we have in this halogenoalkane here. Reaction and the product of these reactant and the products of these reaction are colorless. Halogenoalkanes colorless, water colorless, alcohol colorless, and hydrogen halides are colorless. All these are colorless. So the first point we need to take care, or we need to discuss in this reaction, it's how we can measure the rate of this reaction. The first point we need to discuss in our syllabus, how to measure the rate of these reactions, the reactant colorless liquid and the product colorless or soluble liquids. So how we can measure the rate of reaction. This is the first point we need to talk about it in this syllabus. Our main point is HX. HX here, if you remember from our previous study, X can be chloride, bromide, and iodide. I know when I mention these three ions, your memory should recall something. Yes, exactly. It's silver ion. Okay. These ions react with silver ion to form an insoluble solid. So when HX form, it's a soluble substance. Okay, it will ionize to give the halide ion in the solution. So in the reaction mixture, what we will have alcohol. If there is unreacted water, for example, and hydrogen halide, which can be hydrogen chloride, hydrogen bromide, or hydrogen iodide, which is soluble, and dissociate to give halide ion. Okay, what will happen now? Halide ion react with silver ion, as we know, to give insoluble solid. So we will depend on this point. What we will do? We will depend on this point to find rate of reaction. We can measure rate of solid formation. We will find the rate of solid formation, okay, to calculate rate of reaction. As halide form, which is came from here, okay, due to this reaction, it will react with silver ion, which will add it to the reaction mixture, okay, and form an insoluble solid. We can calculate the formation of this solid and its rate of formation, and then we can measure the rate of reaction. Okay, طبعا source of silver ion will be added amount of silver nitrate to react with the mixture. This is one of important points about our syllabus in this topic. Okay, we will add silver nitrate, which will dissolve to give me silver ion and nitrate. I will ignore nitrate here, and I will talk about silver, which will react with halide to form one of the following solid precipitate. If our halide is chloride, it will be silver chloride. If my halide it's bromide, it will be silver bromide. If it is iodide, it will be silver iodide. And we need to take care of something. Okay, Rx, it's organic. Okay, it's organic, and AgNO3, it's inorganic, so they will not mix. Silver nitrate, it's insoluble, it's inorganic, and the reactant here, alcohol, halogenoalkane, and the alcohol are organic products. So we will face a problem in how they will mix. Okay, so what we will need to do, ethanol used as a solvent. Ethanol, one of unit 3 questions. Okay, how we can deal with this experiment, because two layers will form, one for silver nitrate, which is an inorganic product, and the other reactant, which is organic, and they will not mix. Two layers will form. So I will add ethanol, which will act as a solvent for both of them, which will help me to avoid formation of two layers. One layer will form, both will dissolve in ethanol, so the reactant will the silver nitrate and the other substance, which is in organic product, will mix and start form the solid due to the precipitation of the reactant. Now we need to keep all other variables constant in this reaction. Keep temperature constant, concentration constant, and the quantity of halogenoalkane which added, we need to keep it constant. And another thing, timing of appearance of precipitate. In this experiment we can study the reaction in two ways. The first way, by adding measure the time till precipitate start form. Okay, it's like or time till specific sign disappear. Okay, we don't have a fixed experiment in our syllabus, but if you remember the experiment of sodium thiosulfate, we can follow the same thing. Okay, we can put X sign, for example, and wait till X sign disappear. We need to take care from timing. So our practical part in this experiment, we have two layers because we have organic and inorganic reactant. We will use ethanol because ethanol will dissolve the organic and the inorganic reactant to form one layer. We need to keep all other variables constant, temperature, concentration, and the amount, and take care from timing. I will stop here and we will complete our topics in next video, inshallah. Assalamu alaikum wa rahmatullah.